This entire radiance field is made from voxels. That's right, this is SVRaster, the voxel-based rasterization tool from NVIDIA. Fitting that I use their sign, right? Well, based off of an overwhelming demand for me to make this tutorial, I'm finally here to show you how to do this step by step. And this is, to me, a quick tutorial because it installs and trains really fast. I think the scene I just showed on the screen trained in like 12, 15 minutes, something like that. About 3 times faster than normal Gaussian splatting training. So like all my videos, I have a custom forked GitHub repository. I'll link it in the description, and you can follow along as I walk you step by step through installing the project, pairing your own data set so you can run your own images. And then lastly, we're going to show you how to visualize the data, create a mesh, and do those kind of cool rendering, things like that. So let's jump into my PC and start building this project. So here's my fork GitHub page of Sparse Voxels Rasterizer. And I always have this read before you install. I just want to make sure people understand that this is not exactly what the original GitHub repo has for the project, and that I won't be maintaining it forever. If you want to go to the original GitHub repo, you just go up here where it says NV Labs SVRaster. If you click on that, it'll take you to the original project. But mine has some more tools and instructions on how to run this specifically within Windows. So let's just get to installing. So first off, you're going to need WSL. And if you don't have that, you're not going to be able to run this. And what's WSL? It's a way to run Linux on your PC. So if I right click on this, it's going to bring up a video that I had made, their Inception, me on where I walk you through the whole process. I will link this in the description of this video. Go to this and follow the guide. If you don't have Ubuntu set up on your computer for Windows using WSL. So you might have to do that first. But once you've completed that, or if you already have this up and running, come back. You can also run this all straight in Linux. The next thing you need to do is we need to create a conda environment. So the first thing I'm going to do actually is launch my Ubuntu install. And so it'll look like this, just a simple command line. I'm going to make this really big for you all. And then we need to create a conda environment. So first thing I do is just copy this box, pretty easy. I'm just going to install a shell, basically a little environment where it'll keep the code separate from the rest of the code on my Ubuntu install. So you know it's been activated when it says SVRaster. Just so you know, every time now I run this project in the future, I have to say conda activate SVRaster. And I've already done that, but that will then activate that, or else it says base. As you can see at the very top, it said base. So make sure you run that every time you open up Ubuntu, because you need that to then start activating this project. The next thing you need to do is we need to install PyTorch, and this can be really confusing. I think this is where most people trip up. You have 2 options. Option 1 is for CUDA Toolkit 12.4, and the other one's for 11.7. I suggest doing 12.4. And you can see what version you already have installed on your computer by typing nvcc --version. And you'll see I have 11.8. I also know I have 12.6 on this. So if you only had 11.8 installed, you would want to use option 2. You'd want to use CUDA 11.7. But if you have a newer version of CUDA, you want to use like 12.4. So I have 12.6 also installed, so I can get away with this one. That might be really confusing, but all I'm trying to say is you either have CUDA Toolkit 12.4 or newer, or 11.7 or newer. If it's under 12.4, you want to use this one. If it's over 12.4, that one. Kind of confusing. So I'm going to use this one, and all I have to do is, again, click this top line. It's going to install this PyTorch. It's kind of a large install, but it will go ahead and download it. I'm going to fast forward this because no one wants to sit and watch me install this all. Okay, so now it's done. And so all I have to do now is install the matching CUDA Toolkit install tools right here. So basically just going to take that line. You can, again, click that to copy it and paste that in. Now, if I did, let's say, have CUDA Toolkit 11.8 on my computer, not a newer version on my Ubuntu install, I would have followed these 2 lines. So basically copy, paste that line, copy and paste that line. Simple. If you find the top one's not working, maybe try the other one. You'll find out after this step if it worked or not. So now I'm going to go and I'm going to pull the source code. So now I have the code from the original repository where it's going to grab it from, and I'm going to clone that. All right, super simple. It wasn't a large project. It clones it really quick. And now you can also see I'm in the SVRaster folder. So now I'm no longer working on my computer in the home drive. So to find where all my files are is I'm going to go to here where it says Linux. I'm going to go to my Ubuntu install, go to home folder, my user folder, and then I should have, SVRaster. And so this is where it just pulled all the code, but it's not installed correctly yet. It's like you basically just transferred the files from the website to your computer. So now we need to build that. Super, super easy. So the first thing we do here is pip install our requirements. I'm gonna paste that in. It's gonna install all the requirements. Okay, so I fast forwarded through that. Again, that took like maybe 1 or 2 minutes. And if you don't see any red text, you can see this yellow text. That's fine, but it means it's all successful. Now, if you've been watching my video closely, you'll notice this line wasn't there. I had to add that. I forgot about that as well, but we have this pip install ikuda as well. So we're just going to go put that in there. Okay, so that's done. And again, took a couple minutes. Almost there. Now we install the visor. Just copy and paste that last one like so. And it's going to install a visor, which is a way to dynamically view our results. It's installed. Super easy. This is probably one of the easiest projects to install. I guarantee if you're going to get tripped up, it was here. Because if you go to the original version, let me just show you. If you go to the original version of this GitHub, it is not super clear if you're not used to this, where it says, install these versions and I may need those. But you for sure need those every time. So I just went ahead and walked it through a little bit more clearly. Okay, so now we want to run our own data because they do, if you go to the bottom of this, they do have some synthetic data sets you can download if you don't have your own, and you can test it out, which is great. But I want to use my own data set. So the first thing you need to do is find the part where it says reconstructing your own capture. There's an example Jupyter notebook you can follow, but I just kind of have my own version in here. You can prepare your data. If you've used Instant NGP or NeRF Studio, you can just use what they use. It's pretty easy. So for example, if I was doing NeRF Studio, it's like, go to my command prompt and I believe it's like ns data prepare something like that. And then images, you just type that all in. If you've done it before, you know what you're doing. Just note, it is not exactly that. You have to add this at the end of your script, camera type pinhole. And same with the Instant NGP. It's been forever since I've used that, but you just got to make sure you're telling to use the pinhole method for your camera. However, I made things as easy as possible for you. I created my own lightweight script, so you wouldn't have to use one of these other repositories that you probably don't have installed. And if you do, I would use those actually. So the first thing I'm going to do is you need to basically download the script that I'd make. And I already noticed I had the link wrong in this, but what you need is this run colmap sh in here. You just go to the top here. It's this guy. You're just going to click on it, and then you're going to download the raw file. And that's what you want. And here it is. I actually have 2 versions, but I want this one. I'm going to grab this one. I'm going to cut it. I'm going to go again to that project folder, which I showed you earlier, which was in my Ubuntu Linux here, SVRaster. And then you're just going to put right here in the root of the SVRaster folder. Mine's not labeled correctly. So there we go. Should look like that. Run colmap.sh, and it should just be in your root folder. So super simple. Grab that file, go back to the instructions, and you got to come back down here. And then you want to make sure that your data is put in the correct data structure on your computer. So again, let's go back to that SVRaster folder, and I want to create a new folder in there. So actually, the way you should do it is here is you type in mkdir data, and it's going to make a data folder. So if I go here, it should say you should have a folder. So I have to refresh this. But there's a folder called data in here, and it should be empty. And so you can create that however you want. You can create that in here, or you can create that through typing in the command. And then you want to then have an images folder with your images. So I'm going to grab one from a different project. So if I just go back one, I have this archived version of SVRaster. Here we go. I have this NVIDIA folder with an images folder, and that's what I want. So actually, I'm just going to grab this NVIDIA folder, I'm going to copy it and paste it into that data folder. And so you should do the same with your images. If it's a video, I will also link a really cool tool that will extract the right images from the video for you in the description if you need that. But what you should have is then you have SVRaster, data, the project in which we're going to call this, and then a subfolder called images. And so I have a bunch of images of this NVIDIA sign from GTC. Fitting because this is an NVIDIA project. And then so you kind of see that where it says you have your run col map, which is an SVRaster folder, a data folder, the name of your project, and an images. And so then we need to then from here run this line here, and it will take that script we just created and turn it into an executable like so. You only need that the first time. I called that out in the instructions. Now that's been converted. We're good. And then we're going to run this run colmap.sh. And then we need to add in the name of that project. And so for me, it was NVIDIA. So I'm just going to type in NVIDIA. And by default, it's going to run this in what's called sequential mode. So it's going to look through all your images, figure out where all they are in 3D space. And if they're not taken all in order, like through a video, or you're just walking and taking a picture, you're going to need to use exhaustive matcher. So if that's it, then you're just going to add this line as well. So you can add that if you want. Here's an example of what it looks like I'm using it, or an example with exhaustive matcher. Just no exhaustive matcher takes a lot longer. So I'm going to hit enter, and it's going to start running. At this point, it's identifying unique features within that image data set. And this might actually take a little while. So let's see here. Okay, so yeah, I had 172 images. Now it's going to run sequential feature matching. With the 172 images on my Dell PC with a bunch of cores, this goes relatively quick. It will go slower or quicker depending on how fast your computer is. Okay, it's all done, and you can see I said elapsed time 1.17 minutes. That's for, I think, the last portion. On my computer, this took a couple minutes, under 5, but it could take a lot longer on your computer depending on your specs and how many images, etc. So at that point, our data is ready to go. I did also want to point out, I didn't show this, but if you don't have Colmap already installed, which you do need, it'll pop up a thing saying how to install it. So at this point, you're pretty invested in finishing this project because you have your data prepped and everything installed. So if you found this video helpful so far, do me a little favor and subscribe to this channel because that means a lot to me. All right, let's get back to the instructions. At this point, I can start generating my voxel-based splats. So that's called scene optimization. It's pretty easy. We're just gonna copy and paste parts of this at a time. So like so, this we're saying we're calling Python, we're telling it to use the train.py, and we want these next two lines here, like so, space like that. And it's saying we're gonna run eval mode, and what's the source path? And so that is where the data was. And so we know that was in data / NVIDIA. So yours may be like data / I don't know, greenhouse, whatever you're captured or whatever you want to call it. And then we need to know the model path. So that's where we're going to output the data. So I'm going to go model path, and this I'm going to say results, and I don't have that folder, but I'll create it. Results / again, I call this NVIDIA. And that's all I need. At this point, you can hit enter and run. However, there's all these things we can do. There's a thing called a bound mode. So it's basically trying to figure out how to bound the scene. If you leave it by default, it'll figure out between these camera and forward meridian modes. I found that that works fine. I would not even add it in there. But if you want, you can say like use the bound or your sparse point cloud to figure it out. There's these different modes. So if you feel like things aren't turning out the way you want, you can just put in your thing, you can put in -- bound mode. Like so, and then pick one of these. So for example, maybe it's PCD, point cloud. That's what it'll look like. But I'm going to delete that. I found that every time it seems to do a pretty good job picking the right mode. Basically, is it looking forward or did it do a loop around everything? The next thing is bound scale. I just have always left that at 1. I would only play with that if you wanted to start testing after you've got some good results. For scenes with background masked out, you can do white or black backgrounds. That's all, again, very helpful. Just paste one of those in. And then there's some of these other parameters. So encourages rays to stop inside the octree, useful for real world scenes. I want to use that one for sure. So I'm going to copy that guy, paste it in there. Encourage transmittance from either 0 or 1, useful for scenes whose background pixels are white or black. Again, so that one is one you want to use for like a masked out scene. And then there's a couple other ones. It's geometry. So these different models that will give you better geometry if you want to make a mesh out of this. I'm going to give you some tips here. I don't go over everything. So if you want to try these different modes like lambda, master, metric, depth, you have to have master installed on a computer. And I'm not going to go over that. That's way too much to figure out in this one video. Also, depth anything. Again, that's something you can install yourself. At that point, you can test these different modes. Just think about that. And then this last one, save quantize. So it applies quantization. It makes everything much smaller because you'll see the file size is big. So I'm going to run this without that, and you'll see the file size. But I would say if you get down here, it says meshing. It says you want to make sure you ran these two things, lambda normal d mean 001. So I'm going to copy these. If you want good meshing, you want those two things. So I'm just going to add those two. It also says lambda depth sparse, which might also help. I don't know if I already have that one. Let's just put those all in. Let's see what happens. Like so. So I have all these different parameters I'm going to add in there. And so I'm going to run this, and it should just start up as fine. Enter. Okay, so it's going to automatically start downsampling your images and running the scene. You can tell it not to downsample. I used 1080 by 1920 images, so you can use different ways to prevent it. So now it's going to run. If you look at my computer right now, it's running about 25 iterations per second. It's going to take 12 minutes. I find that is pretty true to that, but we're not going to sit here and watch that. But one cool thing is my screen is probably not big enough, but it will tell you the live PSNR and the loss metrics. The PSNR is basically like an indication of visual quality. And let's see here. I think because I have my screen size all off, it should show that to you normally. It's just the way my screen recording showed up. But you want that number to be in like the 20s ranges or in 30s range, because that means you're on even better and better images. So if you manage to get this at like 31 and higher, you know you're gonna have a really good result. If you're in the upper 20s, it'll probably still look good. So I'm gonna let this run, and I'll be back in a second with the results. Okay, everything's done. As it went along, you'll see maybe some warnings, things like that, but I wouldn't worry too much about that. As long as it finishes, it goes to 20,000 iterations. I had a PSNR of 27.23 and ran at 202 frames per second. I'm not exactly sure what that means. And then it saves everything to that results NVIDIA checkpoints folder as a modeled checkpoint. So congratulations. Now you have trained your first voxel-based radiance field. Now we want to go visualize that, and it's super easy. It's one command line. So let's jump into that. I'm also going to show you how to make a mesh out of it and some other options. I don't go over the whole repository. Again, it gets really detailed and you can spend a lot of time going to the minutia, but we're going to hit the main points that I think you want to look at. So if I come down here, there's a measuring FPS. Again, that's just telling you like how fast this can render it on your machine. Don't worry about that. We can render these specific views. I'm going to come back and show you that, but what we really want is this interactive viewer. So I'm just going to copy this line like so, and then I'm going to paste it. Your output path is actually results and NVIDIA for me. So it's wherever I told it to be when I set that up. So I actually misspelled results like that. And you can kind of figure out where your output path is by going to your Explorer my SVRaster, there's a results folder. I might have to refresh this right here. Oh, result NVIDIA. So I said results, but it's result. So I might probably mistyped like that, and then hit enter, and it'll launch your visualizer. If you get a like warning, there's no visor, you're gonna want to go to pip install visor. It's pretty easy. But here we go. So now I can just control click on that. It's going to launch my viewer, and now I can look at the scene interactively. Pretty cool. The first thing I want you to do, though, before you get too far into this, is to get the best view. You're going to turn that width up to 2048, and that'll maximize the like pixels that it's rendering. You're seeing I'm like rendering at 150 pixels per second. This is not the best capture I've ever done, but it does give you a good sense of what you can create. All these things over here are a bunch of people who walk through the scene as I was trying to capture it, but everything else is fairly detailed. And it does this dynamic way of doing large and small voxels based off how it saw it. I only saw the scene from a very small view frustum, so like around here. So, and you can also change your field of view to kind of match what you captured in. So if most cameras captured at like a 45, that's about normal. I used a really wide angled lens, so maybe it's more like 70, and you can then kind of look at it that way. And you can play with all sorts of things, like your near and far clipping. You can see all this voxels. You know, some are big, some are really small, and get these really cool visualizations and play around with it. And you could actually make your own visualizer for this as well. This is just the one they have packaged up with this. There's a couple other things. Q and E will go up and down. You can use WAS to move through the scene however you want. And then look at the different ways you can change your spherical harmonics. That's how many like view dependent colors there are. There's just different render modes. Depth only, normals only, things like that. These are more for evaluation, and you can play with that. And then you can see like the cameras that you use. So those, like, as you can tell, I walked one loop around it. I find that this doesn't perfectly line up very well, and I don't know why, because I obviously didn't walk through the sign. So take these cameras with some not very perfectly aligned with the scene. You can download the view. I'm not exactly sure. You can just download as a JPEG, yeah, to your computer or PNG. And then one last thing is when you open this up, sometimes everything won't be like lined up with your. Some things won't be lined up with like your XY axis. You can click here and you can go to Orbit Origin tool, and you can see if like this whole scene needs to be kind of rotated. So I'm going to do that, and you're just trying to get the scene kind of flat to what it looks like. So there you go. When you're done, just uncheck that, then go back to your GUI, and now you can get a better rotation around things. So that's just a quick and easy way that you can fix your rendering. So jumping out of the viewer, if you close that window, you still hit like Control C to close the act of rendering, because it is still going to keep rendering that visor. So I should be able to exit it with Control C. That'll interrupt it. And then I'm going to show you a couple more things. So let's try rendering a fly-through video. So it's just going to be like our last thing we did with the viz, but instead Python viz is Python render fly-through. We're just going to enter, and you're going to see exactly how fast it's going to be able to render this. So bam, super fast. It's going. And now it put it in this results NVIDIA fly through. So let's see what that looks like. NVIDIA fly through like this. And it creates this kind of crazy fly through video, and it's a loop. So you can get a better idea of exactly what it would look like if you had a custom render as well, because this looks like way better than what I was showing on my visor screen. And that's basically because I also captured it not in this orientation, or I captured in this orientation, but I rendered it in a wide view. So things don't look great, but that gives you an idea. What's the next thing I can do? So I come through here, and the last thing I'm going to show you actually is basically how to make a mesh. So Again, just about as easy as I just showed you everything else. It's Python extract mesh, and come here like so. And then I'm actually going to pick up the last one. If you hit up on your keyboard, it'll bring up your last commands. You can cycle through all of them. So I'm just going to put it in like that. And now it's going to create a mesh of that. So let's take a look at what that looks like. Okay, so it's done. And so again, it's in that results folder. Just open that up on my screen. I have to refresh it. And here we have this mesh, latest, mesh, level 7 through 9. And let's take a look at what that looks like. So the first thing you'll notice is it's upside down. I always notice that. And then it might be green on the screen like you have. I think that's because it doesn't have normals computed. If you turn on a wireframe, you can get a better idea. But you want to go to Tools, actually Edit, Normals, Compute. Let's do per vertex. That's fine. And then from here, I'm going to go and I have the normals checked on, but I'm going to turn off the wireframe. So now you have a better idea what the mesh looks like. So for some reason, I think it's upside down as well. So you can go ahead and flip and translate that. If you don't use this software, it can be kind of confusing, but I'm just going to go ahead and do it. So you get an idea what it looks like that. And so now here it is. Your NVIDIA sign. It's not the best mesh ever, but it's interesting because it picked up surfaces here that were pure white on this sign. So just think about that. You can mesh things that don't have any texture. And if I did this photogrammetry, it wouldn't look nearly this good. And if you want a photo composite onto this as well, you can always do that through Open3D or something like that, which I should probably make a video on later. So anyways, that's pretty much everything I was going to show you today. If you go back to repository one more time, you'll see there's the fusing modalities, things like that. If you want to look into that, you're going to have to do a lot more work, but they do have these great demo notebooks that kind of walk you through it. So you can follow these notebooks and try to do it on your own as well. So with that, you're up and ready to go with SVRaster. I'm really excited to see what you guys create. Again, if you put anything on LinkedIn or Instagram or X or things like that, tag me. I would love to see your guys' results, and I would, of course, share them with everyone. So subscribe to this channel if you found this interesting and want more content like this. I have lots of tutorials, and I realize I need to get back to talking about how to best capture images, things like that. But I'm excited because there's a lot of projects we're going to dive into next. With that, I'll see you guys in the next episode.